Hi everyone, welcome to Data Science Works. In today's session, we'll be discussing about performance metrics in machine learning. So first one is, why do we need performance metrics? So this question is, so recently we have done like various type of models like linear regression we did in my previous videos. Then we did logistic regression, and finally we did naive-Bayes classifier. So if you are new to the channel, you can watch out those videos that explains for a better clarification. So now, for example, why do we need these metrics? So this is the question that is coming to your mind. So let me answer that. For example, you have built a model that classifies, your data set into two classes. So it's a binary classification task. So it is classifying into class A and class B. So one person has trained logistic model. Another person has trained naive-Bayes classifier. So how do we decide which one is the best? So for that, we have some metrics that we evaluate, and whichever metric will give good result, so we'll be going with that model. For example, for some use cases, accuracy might be important. And for some use cases, accuracy might not be a right metric. And for other cases, precision will be the good metric. So depending on the use case, depending on the problem, we decide which metric we want, and based on that, we'll be choosing the model. So that's why we are going to, because we have learned multiple models and now we are in a dilemma, like which one model is best and which one model will perform best and according to our requirements. So let's get started into the performance metrics. So let me share my screen. Yeah. So this is the performance metrics in machine learning. So first of all, we'll be discussing the agenda. So agenda for today's will be discussing different type of metrics, because these are the topics that I have covered till now. Regression I have covered, and classification I have. So in classification, we are going to we'll be discussing confusion metrics. So in confusion metrics is, it's not a metric, but using confusion metrics, we are going to discuss about precision, your recall, your accuracy, and finally the F1 score. So this is the agenda for today. So let's get started. So classification, as we all know, we have a model that is classifying your data set. You have a data set which has, say, 2 classes or say 3 classes. And now you have to classify into class A and class B. So here, what kind of metrics do we use? So let's get started into the classification metrics. So before discussing the metrics that I already told you, so confusion metrics is one of the concept that you have to, be aware of, and it is very important. So let me explain you what does confusion metrics. So the name is also like confusion. So it will have some confusion when you are doing it for the first time, but I'll explain step by step. So it's not confusing anymore. I hope so. So in confusion metrics, you can see the actual. So we are just building a model, and we are interested in the actual values that are already there and predicted. Okay, so what is your model predicting? And we have to play with these actual and predicted. So you can see here, this actual and this is predicted. Now, what are the possibilities? For example, the actual was also positive and predicted also positive. Then actual can be negative and predicted can also be positive. So 2 possibilities are there for actual: positive, negative, and positive, negative. So total 4 we have, right? Positive, 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 negative, then negative, positive, and negative, negative. Now you see this values: true positive, false positive, true negative, false negative. So what does it actually mean? It's confusing, I know. So I have developed a trick just for remembering purpose. It's not kind of formula, but let's go to that trick. So it's a very good trick. So trick to remember. Trick to remember is either your true and false. So it is one of them, and your predicted. So we'll be looking at the true, false and the predicted. So let's decode now. So how? So as I can see, positive, positive, both are matching. Positive, positive, both actual also positive, predicted also positive. So both are matching. That means if they are matching, so we'll be selecting true, right? And what is the predicted? It's positive. So positive, positive, it's matching, so it's true. And what is it is predicting? Positive. So let's keep it as TP. Next, now you can easily decode. I mean, let's start. Positive, negative, both are not matching. So we keep it first item as false. We'll select false. So if they are matching, select true. If they are not matching, select false. So I've selected false and the predicted is positive. So the second term is positive. Next is for this, I mean, I'm making it too long and confusing, but let's go with, I mean, one more time. So negative and positive, both are not matching, so false. And what is predicted? It's negative. Next, the final one, negative, negative, matching, so true. And what is the predicted? It's negative. So this is how you decode. For example, if you are not, I mean, you're drawing a confusion matrix and you're confused, what was my true positive, what was my false positive. So this is the trick. What you have to do, make it as actual, make it as predicted, try different kind of combinations, and first, if they are matching, select true. If they are not matching, select false, and take the second term from the predicted. I hope it, I mean, clear. So now you have drawn your confusion matrix. So now we have to decide, I mean, what does actually it means. So actually you can easily decode from the, I mean, graph itself. So what it is saying is false positive. False positive means actually it was negative, but it is predicted by the model as positive. So it is false positive. Next is actually it was negative. I mean, actually it was positive and predicted was negative. Here, actual was negative and predicted was positive. So false positive and here false negative. And here, I mean, they are matching. So actual also positive, predicted also positive. So true. And here also. So this was about the confusion matrix. I know, I mean, it will be confusing, but using this trick, I guarantee that you'll be definitely remembering this, how to draw this metric, and in a few go, you are good to go. So now we have decided, decoded the confusion matrix. Now we are going to play with this confusion matrix. How? Let's check. So for example, true positive. So I mean, if you are still confused, so I have taken a real world example. Like you all know, we have COVID for the last 2 years. So for example, so does it have these true positive, false positive? Does it have any effect? I mean, do these metrics provide any significance in real world? The answer is yes. How? Let's check. For example, if a person has a COVID and the COVID test also detected him as COVID positive. So it is true positive. True negative is person doesn't have COVID and the test also detecting him as COVID negative. So they are, whatever the actual person was, and the predicting is also correct. So this was about. Now let's discuss about false positive. False positive was actually the person was COVID negative. So the person doesn't have any COVID, but the test is showing him as COVID positive. So it is the false positive case. And in false negative, actually the person was COVID positive and predicted as COVID negative. So this is very bad actually, because the person is COVID positive and it is still detecting him as COVID negative. So in COVID, kind of application, if we are building, like how much performance we got, so false negative is the metric that this thing we have to focus on, okay, because we want to detect those persons. So this was about the real world example. Yes, these metrics play a significant role in your real world. So true positive and this confusion matrix. So I hope, all the terms are clear with the help of this example finally. So next is important points to note. So for example, in statistics, if you have learned, so you have gone through what are the type 1 error or what are the type 2 error in hypothesis testing. So hypothesis testing is also, I'm going to cover in the statistics series. So for now, you have to note, like we have type 1 error and we have type 2 error. So type 1 error is false positive and type 2 error is your false negative, right? So keep these things in mind, and we are going to make use of it in the next coming videos. Now is accuracy is the first classification metric that we are going to discuss. So accuracy, all these terms that are written over here are, I discussed about. So accuracy is your correct predictions, like true positive and true negative are your correct, divided by the total number of predictions. So this was your accuracy. So we're going to discuss, does accuracy is always a good metric? No. In case of an imbalanced data set, accuracy will not be a good kind of metric, right? So this was about accuracy. Next is the precision. So precision is basically tells the correctness of your positive predictions, how much you are going to predict, correct positive predictions. So let me frame your question and then you can answer. Precision will be the answer. So we are interested in how many are actually positive, out of the total positive predictions. So you have your model and your model predicted your total, positive predictions. How many are actually positive? So here, true positive are out of true positive plus false positive. So let's derive that formula. Let me go back and show you how. So we are interested in TP divided by TP plus FP. So in this case, TP plus FP, what is common? Actually it's changing, but predictor is positive. So we are interested in the actually positive cases out of the cases that are predicted as positive, because it is in first row. And first row correspond to positive predictions. So I hope, this formula you can easily derive, right? Next is, this question is, one of the most asked question in ML interviews. So now I have started covering things like if the questions, are being asked in the interview, so I am going to cover that. So this was one of the questions. So how does what does a high precision score signify? For example, you have the precision score range will be between 0 to 1. So what does that 1 signify? Okay, and what does that, for example, let's take it as 0.5 as a, middle. So for example, if your model is improving like from 0.5 to 0.6 and it is approaching towards 1 and one model is below 0.5. So what does this signify? So you have to check the formula. So the formula is saying it is the true positive divided by TP plus FP. We want the precision to be high, right? So what we want is false positive to be low. So this so false positive is your type 1 error. So precision is focusing on type 1 error, right? So if your model is, good, so it has a precision score of 1. 1 is, the best. So if it is approaching towards 1, so yeah, your model is performing good. But if it is less than 0.5, that means that means your false positive are larger. False positive is greater. So what does precision is taking care of false positive? For example, if it is precision is higher, but it is not taking care of what it is not taking care. It is not taking care of any false negative, which is your type 2 error, right? False negative is your type 2 error. So it is not taking care of it. And that's about it. So I hope it is clear. Next is recall. So let me frame your question. So how many actually positive out of all the positives in the data set? So that is TP divided by TP plus false negative, right? So let's go to that slide again. So TP divided by TP plus FN. which is out of the all the actual positive, how many are actually positive. So this was about, recall. So now you can easily tell, when a high recall, that means that is approaching towards 1, will have low false negative. So it is focusing on type 2 error, but it is not taking care about false positive. So it is not taking care of false positive, which is your type 1 error, right? So you have false positive and false negative, which is type 1 and type 2 error, depending on your requirement of your problem, that you want to reduce type 1 error or you want to reduce type 2 error. You have to choose the metric, so recall or maybe precision. For example, in the case of COVID application, so what is most important to you? It is most important that the person who has a disease, who has, COVID, is also being detected by the test. This is more important to you, right? So depending on your use case, you can decide between different metrics that I discussed. And a recall is basically the high, 1, when it is approaching 1. So it is good. Next and the final slide for today is F1 score. So F1 score is, so we have precision, we have recall, and they said, let's combine both. So that is what F1 score is doing. So it is basically the harmonic mean of precision and recall. So harmonic mean, right? 1 by 1 plus, your precision plus 1 divided by recall. That when you evaluate, so it will be 2 into precision into recall and precision plus recall. So this is the metric when you're not, able to decide which one is, I have to choose. So F1 score is it combines both your precision and recall. Okay. So that's the metric about F1 score. Now, this is one of the question, I have been asked in interviews, and you might also. So what does high or low F1 score means? So let's go back to the formula. So when the F1 score is high, that means your precision and recall are, good, right? But when your, F1 score is low, when your F1 score is low, you cannot say anything like whether your precision was less or your recall was less, right? We cannot comment anything. But when your, F1 score is high, that means F1 score of 1 is best and 0, which is for worst. So F1 score of 1, that means it has a good balance between precision and recall. Now, what I meant to say is, a good balance, because if you've seen this precision and recall, so there's a trade-off between either you can, focus on the precision and the recall. So these kind of, the trade-off and few more metrics, that's, ROC curve, area under the curve. So these metrics I'll be covering in the next videos because I don't want to make this video long. So we'll be discussing about that, right? So precision, when it is low, for example, your model have a low precision. So what might be the case? What might be okay? For example, you might have an imbalanced class data set. So, or you have not tuned your hyperparameters of your model properly. So that is the case when precision will be low. So these are some of the reasons. Okay, when will be your recall will be low? Okay, for example, same. Either in case of class imbalance or you have not tuned your hyperparameters correctly. So that's all about, what does low and high means and what does each parameter signify, and along with the examples. So that's all for today I wanted to discuss, and I thank you for your, attending this. So that's all for today. Thank you.